Greetings to all of you. Welcome back to Physics Insane, and we are going to cover the topic of variable velocity and the relative velocity, and something about the acceleration and its graphical representation. So, in a recent video, we have discussed the one-dimensional uniform motion, which is only possible if we are dealing with the uniform velocities. But today's video is about variable velocity. So what does it mean by variable velocity? As we have defined, that is, if an object covers equal displacement in unequal time intervals, then it is regarded as variable velocity, or unequal displacement in equal time, then it is also regarded as the variable velocity. So if we have a variable velocity, how to solve the calculations, or what is the possible outcomes that we have to do when we deal with the variable velocities? So we can take the average of the velocities, or we can take the instantaneous velocities. So what are these? So let we try to understand with a graphical representation. So let's suppose we have this kind of motion. This is A and this is B, and these are the coordinates of point A, x1 and t1, and x2 and t2 in case of point B. So the shortest distance between the initial and final point is the displacement, and if we want to find the slope, or we can say the hypotenuse of this right triangle, or the slope of x with respect to t, or different kind of things like tangent theta, all of these are the representations of the slope. So we will have a very smooth analogy of parallel over the base. So we have del x by del t. So the del x by del t, as we know, is velocity. Velocity is a vector. So del x by del t. So if we divide the whole of the displacement covered in different intervals, and the total time, the cognitive time, and divide them, we will get our average velocity. And what is the instantaneous velocity? So instantaneous velocity is also a kind of average velocity, but with a interval of time with very short. Let's suppose this is the A and B, and this is a static kind of motion, and we have to discuss only this slope. So we will get the slope, or the dx by dt, or the tangent theta, with a limit case, which is that the time interval should approaching to 0, del x by del t. So here is, so this is the velocity which is instantaneous. So now we have the analogy for the relative velocity. So what does it mean by relative velocity? So far we have discussed about the frame of reference, and we have created a beautifully designed video on frame of reference and coordinate system in our playlist. So all the parameters till now that we have discussed is with respect to the Earth as a frame of reference. But what if we want to take the calculations with respect to some other frame of reference? So here is a case. Let's say we have car A that is moving towards this direction with the velocity of 40 km per hour, let's say, and another car which is traveling with 30 km per hour. So this 40 and this 30 kilometers of A and B cars are with respect to Earth. So what does it mean? What does we do if we want to take the calculation of A with respect to B? We are sitting in car B and we want to estimate the velocity of A. Then how does it work? So a beautiful analogy of velocity of A with respect to B will be equal to velocity of A with respect to E. E means Earth, which is 40 kilometer, minus velocity of B with respect to Earth, which is 30 kilometer. So what is the physical significance of this minus VBE? So this shows that we are taking the relative velocity, and if we minus the velocity of B with respect to Earth, we are stopping this car, or we are going to done the velocity of car B as 0, and when the velocity of car B is 0, we are now to evaluate the velocity of A. This is the physical interpretation of this VBE. So this is the case when both of them are traveling in same direction, and if they are traveling in opposite direction, then we will add them. So these are the analogies of relative velocities. They will be very helpful in numerical kind of applications. So the next thing here is the acceleration, which is represented by A, which is the time rate change of velocity. Change in velocity over change. So as we can see that till now we have discussed, we are going to separate the things on the basis of its tensorial rank. We have discussed the distance and displacement, velocity and speed, but we have only one acceleration and no analogy for the scalar approach. So if we try to divide the speed, change in speed by change in time, then we get the amplitude of the same acceleration. So acceleration, it has the units of meter per second square, and it is the second derivation of the position with respect to time, plus they might be positive, negative or 0. If the acceleration is negative, it is termed as retardation or deceleration, which is a negative acceleration as well. So the next thing is that its graphical approaches. So if we discuss 3 of the approaches with velocity time graphs, so if our object is at rest, then we get this kind of graph. If we have same I must say the constant acceleration, then we have this kind of graph, and if we have non-constant or non-linear acceleration, then we have this kind. There are 2 cases of this in, let's say, position time graph. As we have discussed it is a second derivative of position. So for positive case, it is this kind of graph, and in negative this is this kind of graph. So this is about the acceleration. There are some other kind of things that we will discuss in our next videos. So far we have discussed that the variable velocities, which is the equal displacement in unequal intervals, and we cope up by the average and instantaneous velocities, and what is the physical significance of them we have discussed through these graphs, and what is the calculations and what is the limit case for the instantaneous velocity. Then we get to know about the relative velocities, what is the frame of reference, and how does we cope with that, and how to manage the frame of reference if we want to get the values of velocity of car A with respect to B. We minus that in case of similar direction, and we add it in case of opposite directions, and the acceleration is the time rate change in the velocity change, and there is no expression for the speed rate change. This is the These are different cases of it. And that's it for today's video. We will discuss it in a later discussion about different kind of motions like projectile and other kind of things. Till that, keep vibing, stay blessed.